Inverse functions. Let's consider this function machine with the operation plus 3. If the input is 5, we add 3 to it, means the output is 8. If we want to work backwards, we need to perform the inverse operation, which in this case will be subtract 3. So 8 will go in, subtract 3, 5 will come out the other side. Notice that the input of the first function is the output of the inverse, and vice versa. If we start using some function notation, this x plus 3 is what we'd have instead. So let f of x be x plus 3, and the input being x, call the output y. We then have a relationship with x add 3 is y, so y is equal to x add 3. If we now work backwards, we subtract 3, so y goes in, subtract 3, x comes out. So x is equal to y subtract 3. In function notation, to denote the inverse of f of x, we use the minus 1 exponent. So we write f to minus 1 of x is equal to x take away 3. In this first example, we've got to find the inverse of f of x equals 2x plus 1. So with any problem like this, we want to rearrange it. So let's have y as another variable equal to 2x plus 1. And we're going to rearrange it to make x subject. So y is equal to 2x plus 1. The first thing we're going to do, the opposite, we start off with x, we times by 2 add 1. So to undo it, we need to subtract 1 first, then divide by 2. So x is equal to y minus 1 all over 2. Replace it with the function notation and replace y with x. F to the minus 1 of x is equal to x minus 1 take away 2. Okay, so your turn. Find the inverse of g of x is equal to 3x minus 5. So use the previous example as a guide. Pause the video, have a go and come back and see how you got on. So y is 3x minus 5, so whatever x is, we're going to multiply by 3, then take away 5. So we want to undo that, we need to add 5 first, then divide by 3. So x is equal to y add 5 all over 3, or in terms of g of x, it's g to minus 1 of x is equal to x plus 5 all over 3. This time we've got fx is x minus 3 all squared take away 1, and the domain is x is greater than 3. This is because for a function to have an inverse it must be 1 to 1. We could have had x is less than 3, that would be the other side of the parabola when you sketch it. So f of x is x minus 3 all squared minus 1. Let's have y equal to that and start to undo it. So we had x, we took away 3, we squared then took away 1. So undoing that, let's add 1 first of all, give us x minus 3 all squared. Then let's square root both sides. So x minus 3 is the square root of y plus 1. And then x is 3 plus the square root of y plus 1. So we put that into our notation. F to the minus 1 of x is 3 plus the square root of x plus 1. Okay, your turn now. Try it where g of x is equal to the square x plus 6 all squared plus 5, where the x is greater than minus 6. So y is equal to x plus 6 squared plus 5. Let's subtract 5 first, then square root it, then subtract 6. but right is minus 6 plus the square root of y minus 5. So there our g to minus 1 of x is equal to minus 6 plus the square root of x minus 5. Now, going back to what we said earlier about the input of one function is the output of the inverse. Now our domain for g of x is greater than minus 6. Now if you look at your inverse, what is the range of the inverse of g? Well, square root cannot be, will only be positive, so, or 0. So that means that it's going to be greater than minus 6, which is the domain of our function. So the range of our inverse is the domain of the original function. And with this one here, the domain x has to be greater than or equal to 5 to go into the inverse. You can't square root a negative number. And the range of g is greater than or equal to 5, because x plus 6 all squared can be 0 or more, so therefore g of x can be 5 or more.